Good day to you. This is the second example for the binomial distribution, and pretty straightforward example. There's a couple of key points in it that I want to point out, and the rest is mostly computational. But in this example, suppose that 20% of all college students smoke cigarettes. A sample of 18 students is selected randomly. What is the chance that at least 5 of these students smoke? And so here, if I let X be the number of students out of 18 that smoke. Okay. Well, X here qualifies. It makes sense to model this as a binomial random variable because I've got 18 Bernoulli trials here. It's reasonable to assume that, well, for these purposes, we'll assume that the results of each trial, the trial being asking the student whether or not he or she smokes. It's reasonable to assume that those are independent if these students are selected randomly. And so here, I'm going to assume that X is, or a reasonable assumption here is that X is binomially distributed with n equals to 18 number of trials and p equals to 0.2. So given that 20% of all college students smoke, the chance that any given student that we ask will smoke, we're going to assume that translates to being 0.2. Alright, so what we're after here is the probability that at least 5 students smoke. So that means that the number of students here, X, is greater than or equal to 5. So 5 being the smallest. Well, what I have to do is, alright, so that's the probability that X equals 5 plus the probability that X equals 6 plus ... the probability that X equals 18, right? That's really, gosh, each of these is a binomial probability, so I've got really, so 13 in there, 14 in there to compute. That's a lot of times to use that binomial PMF probability, the probability distribution function. It's a lot to compute that. So what I want to do is recognize that this is actually equal to 1 minus the probability that X is less than or equal, we'll say less than 5. And this is by the complement rule. Okay, well, that is equivalent to the 1 minus the probability that X is less than or equal to 4. Okay, now the probabilities that we need in order to get this probability, by the way, this is called a cumulative probability. It's the probability up to the point 4. What we need to get this probability is the sum of 5 probabilities, which is more manageable than all of these probabilities up here. Alright, so this is the probability that X equals 0 plus the probability X equals 1 plus the probability X equals 2 plus the probability X equals 3. I'll learn out of space here. Plus the probability X equals 4. Okay. Hopefully you get the idea. Well, that is 1 minus So now it's just a lot of computation, really. I've got to evaluate 0 at this particular probability mass function, a probability distribution function, rather. So what I've got here, n is 18 and p is 0.2. This is the value that this is where I'm going to evaluate the function, distribution function at. I'm going to evaluate it at 0 first. So I've got 18 choose 0 times p here is 0.2 raised to the 0th power times 1 minus 0.2 raised to the 18 minus 0 power. Okay, got to do this 4 more times. So this is plus 18 choose now 1 times 0.2 raised to the 1 power times 1 minus 0.2 raised to the 18 minus 1 power plus this probability now. That would be 18 choose 2 times 0.2 raised to the 2nd power times 1 minus 0.2 raised to the this is 18 minus 2 power plus this probability here is going to be 18 choose 3 times 0.2 raised to the 3rd power times 1 minus 0.2 raised to the 18 minus 3rd power plus this probability, which is 18 choose 4 times 0.2 raised to the 4th power times 1 minus 0.2 raised to the 18 minus 4th power. Okay, now I'm going to assume that you all can do each of these computations, and if you do, you will see that the sum of these computations is 0.7163. Okay, and if you take that from 1, you get 0.284. So 0.284 here. So that is the answer to the question here. That, well, the chance is about 28% that 5 or more students will smoke out of this group.